The iron in your blood right now was forged inside a dying star. The carbon in your DNA was built inside a supernova explosion. You didn't just come from this planet, you came from the universe itself. Carl Sagan spent his life proving that, and in one book, Cosmos, he changed how humanity sees itself forever. Who was Carl Sagan? Carl Sagan was a professor of astronomy at Cornell University. But he wasn't just a classroom scientist. He played a lead role in NASA's most historic mission like Mariner, Viking, and Voyager, the very spacecraft that first showed us the face of other worlds. In 1980, he wrote Cosmos, and the television series that followed reached 140 million people worldwide. Why did so many watch a show about science? Because Sagan didn't just explain the universe, he made you feel it. Today, we go through every chapter. Let's go. Chapter 1. The Source of Cosmic Ocean. The cosmos is all that is, or ever was, or ever will be. Not just space, not just stars, everything. Every war, every love, every thought ever thought, all of it inside this one incomprehensible thing. Now here is the humbling part. Our galaxy, the Milky Way, holds 400 billion stars. And there are hundreds of billions of galaxies just like it. If you tried to drive across the Milky Way at highway speed, it would take you several billion years. Earth, on that scale, is less than a grain of sand on every beach on the planet combined. But Sagan doesn't stop at making us feel small. He immediately shows us something that makes us feel extraordinary. He tells us about Eratosthenes, a scholar in Alexandria around 240 BC, nicknamed Beta by his rivals, meaning second best at everything. And yet, this man calculated the circumference of entire Earth. How? He noticed that in the city of Sagan, on the summer solstice at noon, vertical sticks cast no shadow. The sun was directly overhead. But at Alexandria, on the same day at the same time, sticks did cast shadow. He measured the angle of that shadow, compared it to the distance between the two cities, and used basic geometry to calculate Earth's circumference. His answer, approximately 40,000 kilometers. He was almost exactly right. And he did it with sticks, his eyes, and his mind 2,200 years ago. This is Sagan's first lessons. Science is not about equipment, it's about curiosity, observation, and the courage to follow a question wherever it leads. Chapter 2. One Voice in the Cosmic Fugue. 4 billion years ago, Earth was hellscape, no oxygen, no forest, just rock, water, and endless lightning storms. And somewhere in that chemical chaos, in the shallow seas being hammered by energy, molecules bumped into each other in exactly the right way. Self-replicating molecules appeared, and life began. Sagan points out something astonishing. Radio telescopes scanning the dark clouds between stars have found organic molecules, the raw ingredients of life, floating freely in interstellar space. Life's building blocks are not rare. They are scattered everywhere across the galaxy, which lead him to a stunning idea. The origin of life may not be a miracle that happened once on one lucky planet. It may be a cosmic inevitability, something the universe is constantly trying to do. Then comes evolution. Every living thing on Earth, every bacterium, every whale, every oak tree, every person watching this shares the same genetic code, the same 4 letters DNA alphabet. We all are related, all descended from a common ancestor nearly 4 billion years ago. Natural selection, mutation filtered by survival, produced in 4 billion years everything from bacteria to the human brain. And Sagan asks the obvious question, on the other world, orbiting other stars, is this the same process happening? Almost certainly, he believes. The question isn't whether life exists out there, the question is, have any of them made it as far as we have? Chapter 3. From Astrology to Science. For most of human history, people looked at the sky and saw gods. Planets were omens, comets mean disaster. The very word disaster literally means bad star. Astrology tried to connect the movement of planet to human fate, and Sagan gives it a fair hearing. It involved real observation, real mathematics. But then he gives a simple test that destroys it. Twins. 2 people born at the same moment, in the same place with identical horoscope. One dies in childhood, the other lives a long, successful life. How does astrology explain that? It can. But from astrology came something real. Around 600 BC, on the Greek island of Ionia, a group of thinkers dared to ask something different question. Not who made the universe, but how does it work? Thales predicted a solar eclipse. Maximander suggested animals evolved from simpler form. Democritus witnessed a telescope without any equipment, proposed that everything in the universe is made of tiny individual particles he called atoms, and through pure reasoning alone, Democritus concluded that the Milky Way was made of countless stars too faint to see individually. He was right, 2000 years before we could prove it. Then came Kepler, a deeply religious man who believed he was reading God's mind through mathematics. After years of painstaking calculation, he discovered that planets don't orbit in perfect circles, they orbit in ellipses. That planets move faster when closer to the sun, slower farther away. His 3 laws of planetary movements are used today to navigate every spacecraft humanity has ever launched. And Newton completed the picture. The same force pulling an apple from a tree is the same force keeping the moon in orbit, holding planets around stars, holding galaxies together. Gravity, one law, the entire universe obeying it. Chapter 4. Heaven, Hell, and the Red Planet. On June 30, 1908, a fireball blazed across Siberia and flattened 2,000 square kilometers of forest in seconds. The Tunguska event caused most likely by a comet fragment the size of a football field exploding before it even hit the ground. Sagan uses this as a wake-up call. If that happened today over a city, we might mistake it for a nuclear attack and launch our weapons in response. A comet fragment could start World War III. He then turns to Venus, Earth's twin in size but a vision of hell. Surface hot enough to melt lead, crushing pressure, clouds of sulfuric acid, and the cause, a runaway greenhouse effect. Carbon dioxide trapped that heat, temperature spiraled, ocean boiled away, the planet died. Sagan writes this chapter as a warning he couldn't be more direct about. We are also changing Earth's atmosphere. The difference between Earth and Venus may only be a matter of degree. Then Mars. In 1976, NASA's Viking lander touched down on Martian soil, the first mission built by humans to successfully land on another planet. The images they sent back showed ancient riverbeds, dry lake beds, clear evidence that water once flowed on Mars in enormous quantities. Was there life? The chemistry experiments were inconclusive, but Mars still holds secrets. And Sagan urgently believed, that understanding it is not just scientific curiosity, it is part of understanding where life can exist and where humanity might one day need to go. Chapter 6: Travelers. In 1977, NASA launched Voyager 1 and Voyager 2, and Sagan helped to design the mission. These spacecraft use a rare element of the outer planets, one that only happens every 176 years, to slingshot from Jupiter and to Saturn to Uranus to Neptune, using each planet's gravity as a free boost. The images that came back stunned the world. Jupiter, not a smooth gas giant, but a crawling storm system. The Great Red Spot, a storm larger than Earth that has raged for centuries. Jupiter, innermost large moon, the most volcanically active body in the solar system. Active volcanoes erupting sulfur, constantly resurfacing the landscape in yellows, orange, and blacks. Europa, perfectly smooth, covered in cracked ice. Beneath that ice, tidal forces from Jupiter's gravity keep a liquid water ocean from freezing. A liquid ocean right now on a moon of Jupiter. If life needs liquid water, and on Earth wherever we find liquid water, we find life, then Europa may be the most important world in the solar system after Earth itself. Titan, Saturn's largest moon, a thick atmosphere of nitrogen and organic molecules, a world that chemically resembles early Earth. Sagan describes how one image of Europa travels. Light bouncing off that moon's surface crosses 500 million kilometers, enters Voyager's camera, becomes radio signal, travels back to Earth at the speed of light, is received by a disk in Australia, processed by computers in California, and assembled pixel by pixel into photograph of a world no human eyes has ever truly seen. Chapter 9: The Life of Stars. Here is the chapter that will change how you see yourself. Sagan asks, If you wanted to bake an apple pie truly from scratch, where would you begin? Answer: you would first have to create the universe, because every atom in that apple was forged inside a star. Here is how. The universe began with mostly hydrogen, simple single atoms. Clouds of hydrogen collapsed under gravity, heated up, and when temperatures hit about 10 million degrees, nuclear fusion ignited. A star was born. In stellar cores, hydrogen fuses into helium, releasing the energy that makes stars shine. Our sun converts 400 million tons of hydrogen into helium every single second and has been doing so for 4.6 billion years. When small stars like our sun exhaust their fuel, they will swell into red giants, large enough to swallow Mercury, Venus, and possibly Earth, then collapse into slowly cooling white dwarfs. But the massive stars, 10, 20, 50 times heavier than our sun, ends with something dramatic. They collapse into milliseconds. Then the collapse bounces and the star explodes with the energy of a billion suns. A supernova. In that explosion, every heavy element that life depends on, carbon, nitrogen, oxygen, iron, calcium, is blasted into space. These elements drift for millions of years, clump together from new stars, new planets. And sometimes, on small rocky planets, those elements arrange themselves into something that breathes and wonder where it came from. We are made of star stuff, Sagan writes. Your body is the recycled remains of ancient stars that exploded billions of years before Earth existed. That's not poetry, that's chemistry. Chapter 10: The Age of Forever. How did all of this begin? 13.8 billion years ago, all matters, all energy, all of space itself was compressed into a single mathematical point. Infinitely hot, infinitely dense. Then it expanded. The Big Bang. Not an explosion in space, an explosion of space. Space itself was created in that moment. As the universe expanded and cooled, particles formed, then atoms, then gravity pulled those atoms into the first stars. Those stars lived and died and seeded space with heavier elements. New star, new planets, and 4.6 billion years ago, our solar system. The evidence is undeniable. Edwin Hubble discovered that almost every galaxy is moving away from us. The farther away, the faster it retreats. Run that backward, everything was once in the same place. And the cosmic microwave background, a faint glow of radiation detectable from every direction in the sky, is the actual afterglow of the Big Bang, cooled over 13.8 billion years to just a few degrees above absolute zero. We can literally detect the light from the birth of the universe. Sagan notes something beautiful. Many ancient traditions, including Hindu cosmology, describe the universe as passing through infinite cycles of creation and destruction. The oscillating universe theory in modern physics suggested exactly this. Our Big Bang Big Bang may have followed the collapse of a previous universe. Ancient wisdom and modern science arriving at the same idea through entirely different roads. Chapter 12 Encyclopedia Latica. We have sent 4 spacecraft toward the stars: Pioneer 10, Pioneer 11, Voyager 1, and Voyager 2. They are the slowest message we have ever sent. But there is a faster method: radio waves, traveling at the speed of light, capable of crossing the galaxy. Sagan presents the Drake equation, a formula for estimating how many intelligent civilizations exist in our galaxy right now. Multiply together the number of stars, the fraction with planets, the fraction suitable for life, the fraction where life develops, the fraction where intelligence evolves, the fraction that builds technology, and crucially, how long those civilizations survive before destroying themselves. The first several factors produce enormous numbers, billions of potentially habitable worlds. But that final factor is the terrifying one, because every civilization that reaches our technological level also gains the power to annihilate itself. If most civilizations self-destruct shortly after discovering nuclear weapons or their equivalent, the galaxy may be nearly silent. But if even a small fraction survive their own dangerous avalanche and go on the flourish for millions of years, the galaxy may be full of minds far older and wiser than us. Sagan says we need to listen with radio telescope systematically, because if we ever receive a clear artificial signal from another civilization, it would prove something even more important than the existence of alien life. It would prove that it's possible to survive. And right now, that might be the most urgent message humanity could ever receive. Chapter 13 Who Speaks for Earth? And here, in the final chapter, Sagan stops describing the universe. He starts talking directly to us. He reminds us that at the time of writing, roughly half of all scientists and engineers on Earth were working for the military. The same rockets that could carry humans to Mars were being armed with nuclear warheads. One technology, two choices. And then he gives us the image. On February 14, 1990, as Voyager 1 was leaving our solar system 6 billion kilometers from Earth, Carl Sagan asked NASA to turn the camera around to take one last photograph looking back. And there was Earth, a pale blue dot, half a pixel wide, suspended in a beam of sunlight. Sagan wrote, "Look at that dot. That's here. That's home. That's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives on a mote of dust, suspended in sunbeam. From out there, no borders are visible, no flags, no wars, no divisions. Just one fragile, lonely, beautiful planet." He asks, who speaks for Earth? Not any government, not any nation, not any ideology. If we want to survive, if we want to deserve to survive, we need to think of ourselves first as Earthlings, one species on one fragile dot. in one ordinary galaxy among hundreds of billions. His final words in the book: "We are the star stuff which has taken its destiny into its own hand. Our obligation to survive is owed not just to ourselves but to that cosmos, ancient and vast, from which we spring." Cosmos was written in 1980, but it reads like it was written for right now, because the question Sagan asks, who are we? Where did we came from? Are we alone? Can we survive ourselves? Has never been more urgent than they are today. You are the universe becoming aware of itself. You are made of the same atoms that were once inside exploding stars. Don't waste that. Read Cosmos, think bigger, and tonight, look up.